Number 5 on homework, 5B. So Steph Curry makes 90.3% of his free throws. So if he attempts 3, what's the probability he makes one and then misses the second and third? So we have to go back a little bit. So that's probability of make, right? Remember when we do those follow by events, we multiply? I think we did no, not free throws. We did a similar example in the notes. I can't remember I think it was free throws actually in the notes, but it wasn't Steph Curry. So the probability of making is it's 90.3%, but remember we want everything in decimals, so it'd be 0.903. If you do percents, the numbers just don't work out, and you get crazy answers. The probability of missing would just be the opposite of making, so missing would be 1 minus making, which would be 0.903, right? It needs, again, to be in decimal form. Some of us did this problem and did 1 minus 90.3, and we realized we got weird numbers. So the probability of missing would be 0.097. So then we'll multiply times 0.097 twice. And that would be the probability of making and then missing and then missing. And so the probability of making the first one and missing the second two is pretty small, and right, that's because Steph Curry is making 90% of his free throws, so it's pretty unlikely he would miss 2 of them. So it's only 0.0085, less than 1% chance. All right, so now we're just going to say he attempts 6 free throws throughout the game. X will be the number of free throws he makes, and this is binomial because we don't care about order. So if he makes 2 out of 3, or if he makes 1 out of 3 like this previous one, there's more than one way this could happen. It could be make, miss, miss. It could be miss, make, miss, right? But that first one cared about order. So now we have binomial because we have those 2 events, right? He either makes a free throw or he doesn't make a free throw. So that's what makes us binomial. Binomial is whenever we have 2 choices, right? You'll notice we no longer have frequency tables like we did earlier in the homework. That's another reason why it's different, right? Binomial won't have a table like this because binomial is just 2 events, right? This is 9 events, right? 1 through 9. So binomial is different, 2 events. So Steph Curry making a free throw would be a success. And then n is always the total number. So in this example, he's going to attempt 6 times. So n would be 6. N is a total, so n is a whole number. P is the chance of making a free throw, which was 90.3%, but remember we want decimal form. So 0.903. Do not use these percents. The formulas just don't work. And those of you who tried it probably saw that you got crazy numbers. And then Q will be 1 minus P, which we actually already found. It was 0.097. And so that's NP and Q. So what's the probability he makes all 6 of them? So it's not 6 out of 6. It's not a frequency problem. It's a binomial problem. So we're going to use that binomial formula and choose X. So in this case, it would be 6 choose 6. This tells me the number of ways it can happen. And then we're really multiplying probabilities 6 times because there's 6 things happening. So again, that binomial formula is taking care of that multiplication for us with powers. So rather than multiplying 6 times, right, we multiplied 3 times here for 3. We're not going to multiply 6 times because binomial takes care of that. So 0.903, and since he's making all 6, it has a 6 power. And that would be equivalent to multiplying 6 times. So binomial formula is doing that. And then he's going to miss 0 of them. So I'll write the formula. So it's always P to the X and then Q to the leftover powers, N minus X. So since he made all 6, he's going to miss 0. And then anything to a 0 power is 1, so I really don't have to type that on my calculator. Oops, wrong thing. Calculator. So we'll do 6, math, NCR 6, 0.903 to the 6. And anything to a 0 power is 1, so we don't have to type it. So 0.5422. So 54% chance that he makes all 6, right? Each individual one is 90%, but 54% for an individual one. So now at least 5. At least 5 means 5 or more. So that would be the probability that x is greater than or equal to 5. So that means we have to find the probability of 5 or 6. And again, we stop at 6 because there's only 6 attempts. If he was going for 7 or 8, we'd keep going. We already found probability of 6. That was above. So probability of 5 we can find using the same formula. So n choose x. Now instead of 6 choose 6, it's 6 choose 5. It'll be 903 to the 5th power and 097 to the 1st power. So this is telling me the number of ways to make 5, right? Because he could make the first 5, he could make the last 5, or some sort of combination. This tells me that he makes 5, that's why it has a 5th power. And then if he makes 5, then he has to miss 1. So that's why that one has a 1st power. And again, that's multiplying 6 times. It's 5 times and then 1 time. So it is doing the same thing as when we multiplied. So let's go ahead and find that. You probably can use second enter if you still have that on your calculator. Oops. So we'll change it to 6 choose 5. We'll change the power to 5. And then we'll just add the 0.097 to the 1st power. And we get 3494 is the chance of making 5 of them. And then the chance of making 6 we found above was 5422. 5422. And then since we're including both, right, we're doing P of 5 or P of 6, we'll just go ahead and combine them. So 3494. Right, so binomial is not looking at frequencies because there aren't frequencies. It's just a different type of equation. But it's anytime we have those 2 events. So 89% chance, 0.8916, that he makes 5 or 6 free throws. So pretty good chance that he makes 5 or 6. All right, and then mean and standard deviation. Again, we're not using one-bar stat because we don't have data. We have shortcut formulas. So n times p. So in this case, 6 times 0.903. And that gives me 5.418. So on average, he makes around 5.418 free throws. So most of the time, he's probably making 5 or 6 free throws. And then sigma is just, again, a shortcut. We can't use one-bar stat because we don't have data. So with binomial, we don't have raw data. We just have information to use formulas. So we'll do for sigma, the square root of 6 times 0.903 times 0.097. 6 times 0.903 times 0.097. And then we'll take the square root of that. And we get a standard deviation of 0.72495. So by itself, it doesn't mean much, but let's use it to answer to G. So I think most of us probably know it would be unusual for Steph Curry to only make 2. We're seeing right here, right, 89% chance he's making 5 or 6. Or if you know Steph Curry, right, he's probably not going to make only 2 out of 6. But we can use the z-score to check. So we can just check how the z-score relates to things we already know in everyday life. So we'll do 2 minus the mean divided by the standard deviation. And I'm expecting something unusual. 2 minus 5.418, and then we'll divide by 0.72495. Yeah, and we get a way beyond 2 standard deviations, negative 4.715, right? It's very unusual. It's way beyond 2 standard deviations. And we probably knew this was unusual if we follow Steph Curry, but now we can relate something we've seen in everyday life to statistics. I think binomial is probably one of the hardest sections, so if you can get through this one, I think it gets better. But you just have to remember binomial is not the same as any other probability. It's just different. We're not using frequencies. So anytime we have these 2 events, as soon as we're talking about like success versus failure, that's a big hint that we're using binomial. N, P, and Q is a big hint. Yeah, but there's no frequencies, so just be careful that you're not always trying to use the same formulas. Identify what type of problem it is before you start. So binomial is, right, success and failure, and that's what's going on here, right? Making a free throw, missing a free throw.